Hello everyone, welcome to Engineering Explained channel. In this session, I am going to take Basic Thermodynamics Module 1, Lecture 6, that is work. As we know that in the thermodynamics, the energy interactions taking place between the system and the surroundings. The energy may be in the form of work or in the form of heat. And these two forms of energy interactions taking place between the system and the surroundings, so that we have to know these two forms of the energy in detail. In that, I am going to take the first one, work, and there we have to discuss mechanics definition of work and its limitations, thermodynamic definition of work, examples, sign convention. You should know that there are two definitions of the work. One is according to mechanics, another one is according to thermodynamics. First, we'll take mechanics definition of work. The work is done by a force as it acts upon body moving in the direction of force. The work is done by the force. When that force is acting on a body and that body is moves in the direction of the force. If the body is moves, then only we can say that is the work is done. Okay, the force into that distance traveled by that body will gives the work. The action of a force through a distance, the action of that force through a distance, or torque through an angle for the circular motion or angular motion is called mechanical work. The action by the force what it is there for a distance or the rotational motion, okay, that action is a mechanical work. Then the product of the force and distance moved parallel to the force. Okay, parallel to that force only, what distance it is moved is the magnitude of mechanical work. The mechanical work magnitude, what it is there. Okay, that is the product of force and the distance. The mechanics definition of work has some limitations, and these limitations we have to know that first one, it doesn't fully explain the cause of motion. Okay, that is the what is the reason for motion that is not explained fully, especially when dealing with non-conservative forces like friction. When the forces like a friction, those are acting, okay, there it will not explain the causes of the motion. It also does not provide direction of information. Any direction, in which direction the body is traveling, that direction information it will not provide. Furthermore, it focuses on scalar quantities, now only the magnitude, not direction, and may not applicable to microscopic system. This may not be applicable to microscopic systems. These are the limitations, and to overcome these limitations, which can be used in the thermodynamics, and that the another definition that according to the thermodynamics you have to take. Thermodynamic definition of work. In thermodynamics, work transfer is considered to occur between system and its surroundings. Okay, as the work is the form of energy that is occur between system and surroundings. Then what is the definition? The definition is that work is said to be done by a system if the sole effect on things external to the system would be reduced to the raising of a weight. The work is said to be done by a system. This is the work is said to be done by a system. When we say that the work is done by a system, if the sole effect, the total effect, what is on the things, on that whatever the things is, the total effect on that things external to the system, the outside the system, would be reduced to the raising of a weight. That effect, what is there? That if you reduce to a raising of a weight, then we can say that one work is said to be done by a system. And that is the definition of the work as per thermodynamics. Further explanation of this will carry: work shall be done by the system if the total effect outside the system is equivalent to the raising of weight, and this work shall be positive work done by the system. Later we'll discuss while taking the sign convention. The weight may not actually be raised. Actually, the weight may not be raised, but that could be reduced. But the net effect, but the net effect external to the system could be reduced to the raising of a weight. The net effect, what it is there. Okay, if you some arrangements, if you do that one, okay, some imagination, if you do that one, then that effect, what it is there, it should be reduced to the raising of a weight. Then we can say that is according to thermodynamics, work done by a system. Okay, here we'll take this as an example, the piston and cylinder arrangement. Here the piston is initially at this position, and due to the pressure of the gas inside the cylinder, the piston will be moved to certain distance, to this distance, and that distance is given as the L. And the force, okay, the pressure into area, what it is there, that is the force, okay, that will be for acting on the piston. And this distance traveled by the piston will gives the work according to mechanics definition of the work. Then how this can be applied according to the thermodynamics? And this piston movement is there, that is connected to the pulley and the lever arrangement. That means here the lever arrangement, by that the pulley, what it is there, it can turn. It can turn. If the pulley turns, rope connected to that also moves. Okay, the rope will be move in this direction, upward direction. And to that rope, the whatever this weight is there, that will be raised. The weight will be raised. To the rope, the one end weight is connected. The weight is moved at a certain distance here, the z distance. Therefore, the weight is raised. Therefore, here the movement of the piston, what it is there, as per the mechanics work done, we have taken. And here the weight is raising. If you make some arrangement to raise the weight, that net effect, if you reduce to the raising of the weight, then we can say that is also work done according to the thermodynamics definition of the work. This is and the arrangement what we can say for take for the thermodynamics work done. Another example we'll take here. Here there is the arrangement of the running of the fan by the battery. The battery is having the electrical energy in it. And if you connect that to a motor, the motor can turn. It can produce a work. And this motor is connected to fan. Fan can turn. Okay, then that will be producing a rotary motion or a torque it will be producing. According to mechanics, the torque multiplied with the radial distance traveled, that is a work done. You can say that one. But according to thermodynamics, how we can say that one? There is no raising of the weight. And this system, what it is there, okay, that external to the system we are going to take here, because here battery and motor we are going to consider a system, and this is the outside, what it is there, it is the surroundings. Okay, this arrangement will continue, and we'll do some arrangement for the raising of the weight. If the battery is connected to a motor, motor is connected to a pulley, and pulley can turn, and the rope connected to pulley will move in the upward direction, that can raise the weight. And this whatever is there, battery and motor together, what the system we are going to take by the system, if you connect a fan, that can produce a work according to mechanics. If the pulley and weight, if you connect, that will be resist the weight according to thermodynamics. Also, we can say that there is a work done by the system. Then sign convention for this we are going to take. In thermodynamics, by convention, the work done by the system is considered as positive. The work done by the system is considered as positive. But in the thermodynamics, by the convention, it is taken already. And the work done by on a system is considered as negative. On the system, if it is a work done, that is taken as the negative. Here we can see that it's work done by the system. It is a positive work done. Work done on the system, it is a negative work done. When a system does positive work, its surroundings do an equal amount of negative work and vice versa. System and surroundings altogether, if it is connected, then if the system does the positive work, surroundings will do the negative work, equal amount of negative work, and vice versa, that will be there. Thus, in any process, in the process, if it is there, in the thermodynamic process, if you take that is the W system plus of the W surroundings equal to 0. Okay, if the summation of the work done on the system all together, if you consider, the total work done will become say 0. And that further we'll discuss later. Thanks for watching. If you like, share, comment, and subscribe.